Okay. Good morning to one and all. My name is Satish, and today we are going to start a new topic on linear equation in two variable. And I welcome everyone to the sisyaclass. And I would like to briefly introduce about myself. And today we would like to completely dive into the topic of linear equation in two variable as well as quadratic equation. So yeah. So myself, Satish, and I have done my BTech in mechanical, and later I have done my masters in MSc in mathematics from IIT Palakkad. I have 5 years of experience. I have trained around 50,000 students. Now, so this is all a brief introduction about myself. So let's get started and let's try to understand how does the linear equation in two variable works. Okay, yeah. So these are the topics which we are going to cover in linear equation in two variables. The introductory part, the geometrical representation, and we would like to see what are the solution of a linear equation and understand the relationship between the coefficients of linear equation there are two methods in which we can find the solution of a linear equation, that is the substitution method and the elimination method. Let's try to see in parts and understand how exactly it works. Right. So, yeah. So, first of all, let's try to understand the pair of linear equation in two variable. Let's try to dismantle this complete statement and understand in bits and pieces. So, first, what is meant by a pair, what is meant by linear, what is meant by an equation, and two variables. Now, these are the keywords in order to first understand what is the linear equation in two variable. First of all, a pair means it is always two, right? It is like it is always a couple, right? Similarly, a linear means it's a degree of 1, right? You already knew about this. And equation means a statement which holds the equality sign is called an equation. And what is meant by a variable? Which a two variable means it is something which comprises of some values, that is x and y, p, q, m and anything like this. So that is nothing but a variable. So if we try to amalgamate all these statements, we will be understanding what is pair of linear equation. So the general form of pair of linear equation is in the form of a1x plus b1y plus c1, a2x plus b2y plus c2. Now if you understand this, here if you see this x and y are the variable and c1 is a constant, where a1 is the coefficient of x, b1 is coefficient of y, and c1 is the constant. So this is a general form of a linear equation, and this is a general form of pair of linear equation in two variable. Okay, now let's try to understand it with some examples and non-examples. Let's understand what is meant by a linear equation first. So as I said, a linear equation should comprise two variable. A linear equation should have a linear equation in two variables should have two variable. It should have an equality sign, right? So and the highest part or the exponent should be 1, right? So keeping all this in mind, let's try to understand. So what is a linear equation in two variable? Now if you see the first example, this is it an equation? Does this statement have any equality sign? No, it does not have any equality sign. So hence, can we call it as an equation? No, we cannot call it as an equation. Now once I cannot call it an equation, there is no further point of discussing is it a linear or not. So hence it is never a linear equation. Hence it is never a linear equation in two variable. So there is no further discussion in it. Now if you see in the second example, 3x square plus 4x plus 7 equal to 0. Clearly in the second example there is an equality sign. So hence can I call it an equation? Yes, I can call it an equation. But can I call it a linear equation? No, because what is the highest power in this or the highest exponent in this equation? It is 2. So can I call it a linear? No, I cannot call it a linear, right? And can I call it a linear equation in two variable? No, absolutely not. But now if you see the third one, can I call it an equation? Yes, because it is having an equality sign. Now can I call it a linear equation? Yes, because what is the highest power? The highest power is 1. Now you might be getting confused. Why did I write pi? Now pi is nothing but a coefficient. I didn't keep any rule on the coefficient of x. right? I just have said the power of x should be 1, right? But it has satisfied the power. Here the coefficient of x can be any real number. It might be pi, it might be 2, 2.57, 3.33, anything, any number. It can be any number. So is it an equation? Yes. Is it a linear equation? Yes, it is a linear equation. But is it a linear equation in two variable? Now, how many variables are there here? There is only one variable. So I cannot call this as a linear equation in two variable. So I can say it is no, it is not linear equation in two variable. Now if you see here the third example, can you see, is it an equation? Yes, it is having an equality sign. Does it have can I call it a linear equation? Now what is the exponent of x? 1. What is an exponent of y? 1. What is an exponent of z? 1. If you see all the exponents, they are 1, 1, 1. So can I call it a linear equation? Yes, I can call it a linear equation. Can I call it a linear equation in two variable? Please see how many variables are there in this equation, x, y, z. So there are 3 variables. So can I call it a linear equation in 2 variable? No, it's a linear equation in 3 variable. So the last example is, see, 10x plus 3y equals to 5. Does it have an equality sign? Yes, it is having an equality sign. Hence I can say it's a linear equation, and I can create an equation. What is the power of x and y? Both are 1, 1. So can I call it a linear equation? Absolutely yes. And the last one is, can I call it a linear equation in two variable? If you see how many variables does this equation has, it has only 2 variables. Hence I can call it as a linear equation in 2 variable. Among all this example, the last example gives us enough clarity. So we have discarded all these options. This is not a linear equation, this is a linear equation, but this is not a linear equation, this is a linear equation, but it does not have a 2 variable, it has 3 variable, and this has only 2 variable. Now this is how we have discarded the options, and we have understood through an examples as well as non-examples what is exactly a linear equation. Right? Now let's try to further proceed with this topic. Right? Now let's try to conclude also with some definition of what we have learned. Right? A linear equation in two variable, it should basically have an equation. It is basically an equation of the form ax plus by plus c, where a and b are the coefficients of x and y respectively. The c is called the constant, right? Where the highest degree or the power or the highest power is 1, and the last one is how many variables it should have? It should have only 2 variable, and this is one of the example, right? Okay. Now let's try to understand how exactly this linear equation in two variable manifests. That is, how it actually, if you try to draw pictorially on a graph sheet, how does it look like? So let's try to understand how the geometrical representation of this linear equation in two variable looks like. Okay, let's do a small exercise. Okay, now if you see here, let's plot the graph of x plus y equals to 1. Okay, now I would like to show this small procedure of how we can draw this x plus y equals to 1. Now, okay, see here, x plus y equals to 1. Now, basically, in order to plot a graph, we need a coordinates, because we are going to plot this graph on a Cartesian plane or on a 2D plane, right? So, how do we plot? In order to plot this graph, we need to have some coordinates. Now, how do we find the coordinates? It is very simple and very easy. Please see here. First, draw a tabular column. Now, when you draw a tabular column, okay, now what do? Assume any value of x and find the value of y. Okay, so I'm just again writing the equation. Take any value of x. Now, what value of x you can choose? It's up to you. You can choose 0, 1, 2, 3, minus 1, minus 2, minus 2.5, any value you can choose. So, because 0 makes our life so easy, I want to use the value 0. Okay, let's see what is happening. If I take x equals to 0, then what is happening to the y? So, y tends to be 1, right? So whenever I take the x value to be 0, I am getting the y value to be 1. Similarly, is it necessary that every time we need to start with assumption of x value only? No, we can take even the y value also. So take x plus, in place of y, you take 0. Okay. So now what value you got? X equals to 1, right? So when y is equals to 0, you got x value to be 1, right? Now Can we plot this graph on a graph sheet? Yes, we can plot this graph on a graph sheet. But how many coordinates do we have? We have 2 coordinates, right? So the minimum of 2 coordinates are necessary in order to draw a line generally. Okay, so if I have to draw or plot a graph on a graph sheet, so if you see here, this is 1, 2, 0, 0, sorry, 1, 2. So how does it, what are the 2 coordinates we have? 0 comma 1 and 1 comma 0. Now if you see here, where does the 1 comma 0 lies? So this is the point where 1 comma 0 lies. So this is the point where 1 comma 0 lies, and this is the point where 0 comma 1 lies. Now this is the graph, right? Now this is the graph of x plus y equals to 1, right? So this is how the graph looks like, right? Now this was the topic which has been discussed in your 9th grade also, right? How to plot a graph. It is very simple. You might have learned at that point of time, but as simple as that. Right now, I have also shown you exactly how to draw or plot a graph of linear equation in 2 variables. This is just a basic idea in order to know or acknowledge few things in the later part of our discussion, right? Okay, let's go to the further thing. Okay, right now, before we have seen in this graph, right, how many points are there on this line? How many points are there on this line? There are infinite points on this line, right? Now each point is which is lying on this line is called the solution of linear equation. It is called the solution of linear equation. Now whichever the point that is lying outside the line is not called the solution, right? So every point that is lying on a line is called the solution of linear equation, right? So whenever the point is lying on a line, it will definitely satisfy the equation, right? This is one of the small clause. Okay, right. Now you see here we have a question for us. The value of k if 6 comma k lies on a line represented by. So this definitely, is it a linear equation in 2 variable? Yes, right? Because what is the power of x? 1. What is the power of y? 1. We have 2 variable and a constant, hence it's called a linear equation in 2 variable. Just before we have seen every linear equation in 2 variable looks like a straight line, right? And every point on a straight line will definitely satisfy this equation, right? He's already saying this 6 comma k is lying on this line. Okay, now if I try to say that, so suppose this is some line, I'm saying it is some line where this equation of this line is x minus 3y plus 6. Okay, now there is some point here that is 6 comma k. Now I just before I said that every point lying on this line will be satisfying the equation. That means it agrees on this equation, right? Now just you need to do only one thing. In place of x, so the first coordinate is x coordinate, the second coordinate is y coordinate. Just substitute this 6 comma k in the equation, and now let's try to see what exactly is happening. So because 6 comma k is lying on the line, so just substitute in this equation x minus 3y plus 6 equals to 0. In place of x, you substitute 6. In place of y, you substitute k. Now what does it happen? 6 minus 3k plus 6 equals to 0. Now what is 6 plus 6? 12. 12 minus 3k is equals to 0. 12 equals to 3k, and the value of k is equals to 4. Yes or no? 3 4s are 12, right? So this is how we can find the value of k. Now this was asked for 2 marks in 2023. So this seems to be one of the important question, right? Right. Let's see how it goes next. Okay. Okay. So now you see, till now we have learned what is the solution of linear equation, right? How many solutions we have? That means infinite, because a equation is always in the form of a straight line and there are infinite points, there are infinite solutions. Now here, why am I again repeating this topic? No, I'm not repeating this topic. If you see here, I'm talking about the solution of pair of linear equation, right? If you understand here, I'm trying to talk about the solution of pair of linear equations, right? Now, what is meant by solution of pair of linear equation, right? Let's understand this topic. Right. Now, there are 2 ways in which we can actually understand and also find out the solution of a linear equation. The first one is to the graphical approach, and the second one is the algebraic approach, right? The graphical approach is the one where you can actually draw the graphs and understand what is the solution, right? And the algebraic approach is a technique that is, in this algebraic approach there are two methods in which you can find the algebraic approach, that is the substitution method and the elimination method, right? There are two ways in which you can find the solution of a linear equation. Now let's try to understand how does this graphical approach looks like. Okay, now if you see here, now there are three different figures, right? Now when I say solution of pair of linear equations, an equation means there is only one line. When I say pair of linear equation means how many lines do we have? We have two lines. Now how are these two lines correlated to each other? That is what we have used by the graphical approach. We can actually see how the two lines are interrelated to each other, right? Now if you see, if I have to draw two lines, can I, this is one possibility, that is the lines might never intersect only, that is the lines are parallel. Now the second way is the line might intersect at only one point. Now please remember, these two lines are intersecting at only one point. Hence, you can see here how many number of solutions do we have? There is only one solution, right? Right? Can you see here? But are these two lines intersecting at any one point? No, there is not even one point where these two lines are intersecting. So how many solutions do they have? They have zero solution, right? How many solutions do they have here? There is only one solution, right? Now, if you see here, if there is a line, right? Now this entire line is being overlapping on the same line, right? Now how many, so every point is agreeing on this line, right? Every point lying on this line is also agreeing on this line. So can I say that how many solutions do we have? We have infinite solution. Now this is a symbol of infinite, right? So how many solutions do we have? Infinite solution. So what are the three different possibilities that two lines can be related to each other? Either they might be parallel, they might be never intersecting, or they might be intersecting at only one point, or the last one, they might be intersecting throughout and there are infinitely many solutions, right? So these are the different ways. Now let's try to even acknowledge furthermore, but this is how the graphically we can understand how does a two lines are related to each other, right? Right. So right now we have seen, okay, we have seen on a graph sheet how to plot a line and how two lines can be intersected or parallel or they might be coincident. But what if you have, it is a 3 hours exam, right? Now isn't it difficult for every question, right, to draw it graphically, right? It becomes very difficult at each and every point of time. But just by seeing two equations, can we just find out, or can we just say how they are related? Can we find out the horoscope without even just further diving into the graphical representation? Yeah, we can do that, right? Just by looking at the equation without even keeping the pen on the paper, you can just acknowledge that two equations are related. Either they might be parallel, or either they might be coincident, or either they might be intersecting. Either of these three cases without even just looking at the graph, right? Now that is the magic, right? Let's see how does it work, right? Now before that, we will like to hustle up ourselves, or muzzle up our minds for understanding the basic general form of a linear equation, right? This is a small task for you, okay, in order to brush up our basics. So what is the value of ABC? Now this is a general form of a linear equation, ax plus by plus c. Now is this a linear equation in two variable? Yes. Is this a linear? So what is this a called? What is this a called? A is called the coefficient of x, B is called the coefficient of y, and C is called the constant, right? Now let's try to understand this. Okay, so I have given you a linear equation in two variable. Now can you say me what is the value of A, what is the value of B, and what is the value of C? Can you say me what is this value of A, B, and C? Now as I have discussed here, see, if you see here 2x plus 3y plus 7, what is the value, what is the coefficient of x here? A. So what is A? 2, B 3, and C is 7. It is simple. Similarly, can you also see here 2.5x is equals to 2y minus 7. Now first of all, you need to bring this form of a linear equation into the general form. Now, what is the general form we have? Ax plus by plus c equals to 0, right? Now, what do you need to do? First, you need to convert this into the general form. How do you convert this into the general form? 2.5x and bring all the variables and coefficients to one side, minus 2y plus 7 equals to 0, right? Now, if you see here, we have converted into the general form. Now, what is the coefficient of x here? The coefficient of x is what? 2.5. What is the coefficient of y? Minus 2. What is the coefficient of c? That is, what is the constant? That is 7. Now, can you see here? First, we have converted into the general form and then we have written in the form of ABC. Suppose in the question paper, in the question paper, they have given you this sort of an equation. Don't be in a rush to just finally write the answers. 2.52 minus 7. Now you'll get 0 marks, right? You need to first convert into the general form and then write the values of ABC, right? You need to be conscious enough to do this, okay? Right. Okay. Now, let's understand this, okay? Just before I said there is a magic, right? Without even further plotting a graph, we can actually find out a relation. How are the two lines connected with each other, right? Now let's try to see this, okay? So I have said three cases, that is a unique solution. Then I said there's the line no solution and there are infinitely many solutions. Now I have already given you the answer actually. So I have taken two equations, 3x plus 4y equals to 20, x minus 2y equals to 0. For our convenience, because we have learned about the graphical representation, the graph looks like this, right? Now, by seeing the graph, you can say how many solutions do we have? We have only and only one solution. It is intersecting at only one point. Now, but without even drawing this graph, can we conclude? So for now we are going to see how does it work, right? I want everyone to just find out this a1 by a2, b1 by b2, c1 by c2. Now what is a1 by a2, b1 by b2? Just before we have done one exercise, right? That is, can we find, so this first equation is nothing but a1, b1 and c1, and this is a2, b2 and c2. Now can you find out the values of a1 by a2? What is a1 by a2? What is a1 by a2? So what is a1 in the first case? This is 3. And what is the coefficient of x in the second case? That is 1. So can I say this is 3 by 1? Now what is b1 by b2? What is b1 by b2? The b1 by b2 is 4 by minus 2, right? So that will be minus 2. So can you see that a1 by a2 is 3, b1 by b2 is minus 2. Now what can I say about these two ratios? So b1 by b2 is minus 2. Now, can I say that these two ratios are equal? No, they are not equal because this is 3 and this is minus 2. So, can I just conclude that a1 by a2 is not equal to b1 by b2? Can you see this small observation here? Right? Whenever the ratio of coefficient of x and the ratio of coefficient of y are not equal, then I can directly conclude without even seeing the graphical representation. I can just say that these two equations are having only and only one solution. So remember this case, whenever this possibility is there, there is only how many solutions do we have? We have unique solution. So remember this. So whenever a1 by a2 is not equal to b1 by b2, we have unique solution. Now let's try to see the another case. Now let's try to see. Now if you see the graphical representation of these two lines, okay, again I have taken two equations and I have plotted on the graph sheet. If you see here, these two lines are never intersecting. That means how many solutions do they have? They have 0 solution, right? They have 0 solution. There is no solution at all, right? Now let's try to understand again using this concept of a1 by a2, b1 by b2 and c1 by c2. Okay, now this is the task. Can you find a1 by a2? What is a1 by a2? a1 by a2 is 2 by 1. Okay, good. What is b1 by b2? Again 4 by 2, which is equals to 2. So we have a1 by a2 equals to 2, b1 by b2 equals to 2. So let's here only we'll just try to conclude a1 by a2 is equals to b1 by b2. Now is it equal to c1 by c2? Please see here. What is c1 by c2? C1 is minus 12 and c2 is minus 4. So what is c1 by c2 here? It is 3, right? Now can I say that a1 by a2 and b1 by b2 are same, but is it equal to c1 by c2? Is 2 equal to 3? No. So I can say this is not equal to C1 by C2. Now, whenever this sort of a criteria comes into the picture, we can directly conclude without even further drawing the graph that they have no solution. So, this case represents no solution, right? This case represents no solution, right? Yes. Now, let us see here. Now, please here the last one, the last case, that is infinitely many solution. Again, I have taken two equations and have tried to draw it on the graph, and if you see the graph, the two lines are overlapping over each other, right? Now, if you try to, let's try to actually acknowledge it with this sort of a ratios, exactly how are they related. Now, let's try to see, let's try to find out the relation. If what is a1 by a2, that is x coefficient of x by coefficient of x, that is 4 by 2, which is 2. What is b1 by b2? What is b1 here? The coefficient of y and the coefficient of y, which is 6 by 3, which is 2 again. And what is the last one? C1 by C2 equals to, if you see here, if you want to write it in the form of a general form, you can just bring 18 to the right hand side, to the left hand side, and 9 to the left hand side. So, what is our equation becomes? 4x plus 6y minus 18 equals to 0, 2x plus 3y minus 9 equals to 0. But still, it wouldn't matter much. Now, if you see here, it is minus 18 by minus 9. Again, the answer turns out to be 2. So, if you see here, a1 by a2 is equal to b1 by b2. Again, it is equal to c1 by c2. So, what is the relation? a1 by a2, is it equal to b1 by b2? Yes. Is it equal to c1 by c2? Yes. So, can you see here all the three ratios are equal? So, whenever this case pops out, then you can say that it is having infinitely many solution, right? So, let us try to again put it in a nutshell everything. So, if you see the pair of linear equations, right, what is a1 by a2, what is b1 by b2, what is c1 by c2, right? We have just found out that this is 3 by 1, this is 4 by minus 2, right? So, and c1 by c2 is 20 by 0. So, can I say that a1 by a2, is it equal to b1 by b2? No, a1 by a2 is not equal to b1 by b2. Hence, I can say that here it is intersecting lines, and hence it is having a unique solution, right? Now, if you see here a1 by a2, b1 by b2 and c1 by c2, if you see here a1 by a2, it is equal to b1 by b2, but it is not equal to c1 by c2, hence you can say it is having a parallel lines and no solution. And the last case is a1 by a2 is equals to, so what is a1 by a2? 4 by 2, which is 2. What is b1 by b2? 6 by 3, again it is 2, and 18 by 9, which is again 2. So, we can say here a1 by a2 is equals to b1 by b2, which is not equal to c1 by c2, and here we can say that a1 by a2 equals to b1 by b2, which is also equals to c1 by c2. So, we have all these three cases. If we are able to understand this, then it is having, if a1 by a2 is not equal to b1 by b2 intersecting lines, it is, then it is having a unique solution. So, the graph looks like this, right? If the two lines are parallel, like a1 by a2 equal to b1 by b2, which is not equal to c1 by c2, then it is having parallel lines, then it is having no solution, or the last case is coincident lines, right? Okay, right. Let's again dive into some problems and understand how does it go. The value of k for which the system of equations 3x minus y plus 8 equals to 0 and 6x minus ky plus 16 equals to 0 has infinitely many solution. Now, again please turn back your pages and understand what is the condition for having an infinitely many solution. When it can have an infinitely many solution, what is the condition? Just now we have discussed that a1 by a2, if it is equals to b1 by b2, and if it is also equal to c1 by c2, this is the only case where it is having infinitely many solution, right? Now, you see here, what is a1 by a2? 3 by 6. What is b1 by b2? Minus 1 by minus k. So, can I say that if these two ratios are equal, then only the infinitely many solution case is possible. So, can I cancel minus minus? Now, if you see what is this, 3 2s are 6, and if you try to crisscross, then the value of k is how much? 2. So, only when the k value it is equal to 2, it is having how many solutions? It is having infinitely many solutions, right? Now, let's see one more example, let's see one more problem, right? The pair of linear equation linear equations is 2kx plus 5y equals to 7, 6x plus 5y equals to 11 have a unique solution. Now, when is this case possible? What are the conditions under which that two equations are having a unique solution? Let's try to understand this. So, just before that we have discussed that when can two equations have unique solution? What is the relation between a1 by a2? Is it equal to b1 by b2 or is it not? It is not equal to b1 by b2, right? Only when a1 by a2 is not equal to b1 by b2, we can say that it is having a unique solution. Now, what is the a1? What is the coefficient of x here? 2k. Now, what is the coefficient of x in the second equation? That is 6. Now, what is the coefficient of y? That is 5. What is the coefficient of y? That is again 5. Now, he is saying a1 by a2 should not be equal to b1 by b2 because here it is a unique solution. So, right. So, can I cancel this 5, 5, 1. So, can I say that 2k is not equal to 6. Now, when I say that 2k is not equals to 6, that means k is not equal to 3. Now, this is very important statement, right? That means k can take any value on a real number line, but it cannot take 3. Only when the k value is not equal to 3, then it is having a unique solution. In the other case, it is having if k is equals to 3, either it might be an infinitely many solutions or no solution, right? It all depends on the value of c1 by c2. But whenever a1 by a2 is not equal to b1 by b2, then it is having a unique solution, right? Yeah. Now, let's see one more question. This was asked in 2024 exam, right? See, two lines are given to be parallel. The equation of one of this line is 5x minus 3y equals to 2. The equation of the second line can be. Now, here he is talking that the equations are parallel. The equations are parallel. Now, what are the conditions under which two equations could be parallel? What are the conditions under which two equations can be parallel? That is, a1 by a2 is equals to b1 by b2, but not equal to c1 by c2. If these two ratios are in proportion, and if these two ratios are not in proportion, then we can say that the lines are parallel or it is having no solution, right? It is having no solution, right? Now, let us try to analyze by option verification, right? Now, if you see for the first option, let us try to find the a1 by a2 relation. 5 by minus 15. What is b1 by b2? Minus 3 by minus 9. And what is the last one? That is 2 by 5, right? So, if you see here, a1 by a2, if you see here, a1 by a2 and b1 by b2, right, these two are not equal. Hence, I can say that this condition is false, right? a1 by a2 5 by minus 15, b1 by b2 minus 3 by minus 9. It is these two ratios. This is minus 1 by 3 and this is plus 1 by 3. So, there is no further point of discussing what is with the 2 by 5, right? So, hence this is not the case, right? If you see the next one, right, a1 by a2 5 by 15, it is equals to what is b1 by b2 minus 3 by 9, and what is c1 by c2? That is 2 by 5. So, if you see here, this is again, right. So, a1 by a2 is equal to b1 by b2, it is not equal to b1 by b2. So, again there is no further point of discussing c1 by c2, right. Like this only we can further verify with the third option and again with the fourth option, right, and this is how we can find the solution of a equation, right. Right now, we are seeing into the further case, that is, as I discussed the algebraic method. Now, there are three different ways in which we can actually find out the solution of a linear equation. Till now, we have found how are two lines connected over each other, right? Either they might be parallel, intersecting, or they can be coincident. But what exactly is the solution, we have never found out, right? Now, this is a technique in which we can find out exactly if they are intersecting, what is the exact solution. So, let us see, there are three different ways in which we can find out the solution of a linear equation in two variable, that is substitution method, elimination method and cross multiplication method. So, right now we will be completely understanding what is a substitution method and an elimination method, okay, right. Now, let us understand this substitution method, right. Okay, now this is one of the easiest technique in which we can find out the solution of a linear equation in two variable, right? Now let's understand with some example instead of formally dictating some points, right? Now let's consider these two equations, x plus 2y equals to 8 and 3x minus 2y equals to 12. Now how can we find the solution of these two equations? How can we exactly find the solution of these two equations? By substitution method. Now for the substitution method, if you understand this word called substitution, substitution means what? So if you see in even in the cricket, in football, one person would be replacing the other person, right? They would be substituting the other person. The similar analogy we would like to understand even in the mathematics point of view, right? We would like to take the same procedure, that is substitution in one place of the another, right? Right, for that it goes, we would like to mimic the same concept, right? How does it go? If you see the first equation, consider any one of the equation. After considering any one of the equation, consider any one of the variable. Okay, so for example, I am considering the first equation. Okay, that is what, x plus 2y equals to 8. Now once I have chosen this equation, what do you need to do? You need to consider any one of the variable. I am considering the first variable, that is x, and shift all the other variables to the right hand side, that is 8 minus 2y, right? So this x value we got from the first equation. Now whatever we have got this first equation, we need to substitute from the another equation, that is the equation that we haven't capitalized till now, right? So this is my first equation and this is my second equation. See, we got this value of x from the first equation itself, right? What I have done, I have taken x on one side, I have shifted all the other values to the right hand side, and just keeping this disclaimer that the coefficient of x should always be 1. Right, now try to substitute this new equation which has been adopted from the first equation into the equation 2. Now just in place of x you need to substitute this. So 3, what is the value of x we got? 8 minus 2y is equals to 12. So we have 24 minus 6y minus 2y is equals to 12, right? Now 24 minus 6 minus 2 minus 8 is equals to 12. Now we need to just shift the we just need to swap the constants. 24 minus 12 is equals to 8y. What is 24 minus 12? That is 12 and is equals to 8y. So from here I can write 12 equals to 8y. So the value of y is equals to 12 by 8, which is 3 by 4. It's done. You got the value of y to be how much? 3 by 4. Once you got one of the variable, can you substitute in the other variable? That is x equals to 8 minus 2y. Just in place of y, substitute 3 by 4. 8 minus 2 into 3 by 4. So this will be 8 minus 3 by 2, which will be 16 minus 3, that will be 13 by 2, right? Now this is how you will find the this is how you will find the solution using substitution method. Now we need to, again I am just repeating this procedure once again. When the two equations are given, choose any one of the equation. After choosing any one of the equation, choose any one of the variable. From that variable, keep that variable on one side, shift all the other variables and the constant on the other side, substitute in the opposite equation. So we got this from the first equation, substitute in the second equation and do the procedure. This becomes an equation in one variable. Once you have equation in one variable, it is very easy to solve. Once you have solved, once you have found out the value of y, substitute in the any one of the equation in place of y, and then you will get the value of x. Now this is how you will find the equation, this is how you will find the solution of a linear equation in two variable using substitution method, right? Now let's understand this very quickly again with one of the PYQ previous year question. Solve the following linear system of equation 2p plus 3q. Here p and q are variables, don't get confused that x and y, p and q are variables. So 2p plus 3q equals to 13 and 5p minus 4q equals to minus 2, right? Now let's try to understand this, let's try to solve this linear equation in two variable by substitution method. Now how do we do this? Choose any one of the variable, okay, choose any one of the equation, okay. So this is equation 1, this is equation 2. Now choose 2p is equals to 13 minus 3q. So p is equals to 13 minus 3q by 2, okay. So this is what I got the value of p. What did I do? I choose one of the equation and then I have choose any one of the variable. I have chosen the p. Understand this, the coefficient of p should be equal to 1. Now you substitute this in the equation 2. Now 5 in place of p, substitute this 13 minus 3q by 2 plus, sorry, okay, minus 4 times q is equals to minus 2. So this will become 13 5s are 65 minus 15q is equal minus 8q is equals to minus 4, right. So 65 minus 23q is equals to minus 4. So now if you try to rearrange this, 65 plus 4 is equals to 23q, and this turns out to be, what is 65 plus 4? 69, and which is equals to 23q, and the value of q is equals to 69 by 23, which is equals to 3. So what is the value of q? The q value is equals to 3. So once you got the value of q, substitute any one of the equation and you will get the value of p, or you can just directly substitute in this. So if you see here, p is equals to 13 minus, what is the value of q? 3 into 3 by 2. So what is this? What is 13 minus, what is 3 3s are 9, 13 minus 9 is 4, 4 by 2 is 2. So we have got two values, that is the value of p is 2, the value of q is 3. Isn't it very simple, right? Right. Now the linear equation in two variable is not just confined to solve some sort of a equations in two variable, right? We can also solve enormous number of word problems, right? Now let's try to understand, let's try to actually use some real life examples that we can actually solve a linear equation in two variable, right? And this linear equation in two variable has a wide spread of concept. Even you can use this concept in some sort of a concept like linear programming problems, right? It is called LPP, or in the concepts of operational research. Now these are somewhat we'll be using in the engineering and in our daily life, right? So let's try to understand basically fundamentally how do we use this, okay? So here there is the question, the larger of two supplementary angles exceeds the smaller by 18. Now what is meant by supplementary angle? What is meant by supplementary angle? A supplementary angle means the sum of angles should be equal to how much? The sum of angles should be equal to 180, yes or no? So let one of the angle be x, let one of the angle be y. Now that's a simple case. Whenever you see supplementary, it is 180. Whenever you see complementary, it is 90. So let the angles be x and y, right? Now he is saying it is a supplementary angle, so definitely the sum of angles should be equal to how much? 180. And he is saying the larger of two supplementary angles exceeds the smaller by 18. So suppose if I have chosen the larger angle to be x, it exceeds the smaller, so the smaller angle is y, it exceeds the smaller by 18, matlab we need to go 18 steps forward from the y in order to reach the x. So we need to go 18 steps forward in order to reach the x, right? From y you need to go 18 steps forward, right? That is what it makes. So if you see, this is my equation 1 and this is my equation 2, this is degree, okay? Now how do we solve this equation 1 and equation 2? It is simple, again use the substitution method. In place of x, just substitute. So y plus 18 plus y, I am directly substituting this value y here, right? I am trying to substitute directly y plus 18 in the place of x, so which will be 180. What is y plus y? 2y, which is equals to 180 minus 18. What is 180 minus 18? What can you say 180 minus 18? It is 162, right? So the y value is 162 by 2, which will be 81. So you have the y value to be 81. So once you have the y value to be 81, what will be the value of x? Just substitute here. x is equals to 81 plus 18, which is equals to 99. So do we have the, did we find the two values? See, by using the simple technique of linear equation in two variable, we have convert a mathematical problem, a English literature problem, into a mathematical expression and an equation, and we have found out, without even further go, we have found out the two culprits, that is y and x, using this technique of linear equation in two variable, right? And also we have used this substitution method, right? So we can use this technique even in the real life examples also, right? Daily problems also. Now the second technique that we are using is elimination method. Now this elimination method is much more easier and much more smoother when you compare with the substitution method, right? It is like this method would reduce your calculation error, right? It is very simple and it compromises in there's some compromising even in the steps also. You can quickly find the answer within less span of time, right? Now let's see here. Right. So let's try to understand. We have solved these two equations. If you remember, in the substitution method, we have taken the two equations, but we have solved using the substitution method. But now the question demands by elimination method. How do we solve by elimination method? So we have 2 x plus 2y equals to 8, 3x minus 2y equals to 12. Now everyone please listen very carefully. Okay, now this elimination method is super duper easy. Okay, how do we use that? How do we do that? If you see here, the technique goes like this. First of all, be very conscious about the coefficient of the variables. Now what is the coefficient of x here? 1. Coefficient of y is 2. Coefficient of x is 3. Coefficient of y is 2. Irrespective of sign, please make sure if any one of the coefficient is same, or if you could make it same, right? If you could make the possibly the coefficient of x in both the equations to be same, or coefficient of y to be same, then almost the task is completed, right? Now let's see, by default this problem is having some boon, right? If you see here, what is the coefficient of y here? 2. What's the coefficient of y here? 2. So we don't have to do further anything, right? Simply we can do one thing. Can we add these two? Why am I adding? Because if I add, what is 2 plus 2 minus 2? It turns out to be 0, right? You can add or subtract, but be very conscious or be very subtle in choosing the steps whether you should do addition or subtraction. Here I am choosing the addition because plus 2 minus 2 will nullify my complete variable itself, right? So I am choosing that sort of an operation which nullifies any one of the variable. First of all, you need to make sure coefficient of any one of the variable is same, and then you need to just add or subtract according to the signs that we have. Okay, so here I am trying to add. What is x plus 3x? That is 4x. What is plus 2y minus 2y? So this completely gets cancelled, that is 0. What is 8 plus 12? That is 20, right? So the x value is 20 by 4, which is 5. Isn't it simple? Very simple, right? Without even further calculation, very less, minimal number of calculations, and very easy you can solve. So once you got the value of x, substitute in any one of the equation. So I'm just trying to substitute in the first equation. 5 plus 2y equals to 8, and now 2y equals to, what is 8 minus 5? That is 3, and the value of y is 3 by 2. So I got the value of x to be 5 and the value of y to be 3 by 2. So if you see the both substitution method and elimination method is little more easy, and comparatively it consumes less time to solve, and it gives very quick answers, right? Right. So this is how the elimination method works. Okay, right. Now let's try to quickly solve few PYQ problems, previous year question problems. So we have two equations, that is x plus y equals to a plus b, ax minus by is equals to a square minus b square. We need to quickly solve, we need to find the solution. So I would like to capitalize the elimination method because now we are aware of elimination method, right? So x plus y equals to a plus b, and ax minus by is equals to a square minus b square. Now what is the first step I said in the when we are solving the elimination method? We need to keep the coefficient of any one of the variable to be same. But here if you see, the coefficient of x is 1, the coefficient of y is 1, the coefficient of x here is a, and here it is minus b. So what do we need to do? We need to make some changes, right? Now in order to make any one of the coefficient to be same, I am choosing the value, the coefficient, the x, I am choosing the variable x. So if I try to multiply the entire variable with a, what is happening, right? I am trying to multiply entire a to the both on LHS and RHS. It doesn't make any change, right? If you are trying to multiply or add or subtract or divide any number on both sides, there won't be further, disruption in the equation, right? So there is no harm. So again, if we rewrite the equation, this will become ax plus ay is equals to a square plus ab, right? Now if you see here, did I make the x coefficient and x coefficient here are same? Yes, they are same. So can I cancel it out now, right? I want to completely nullify it. How can I nullify it? I can completely remove ax minus ax equals to 0, and I can again change the sign, right? Here I am choosing wisely my operation to be subtraction instead of addition. In the previous case I have chosen the addition, but right now I am choosing the subtraction. Whenever you are using subtraction, just tilt the sign, just change the sign. What is the sign over here? Plus, minus. I have just used plus and minus, so in order to cancel this, here the sign is plus, I am choosing the minus. Here entire sign is plus, I am choosing the minus. So minus by minus ay, so it will be minus by minus ay is equals to a square minus b square minus a square minus ab, right? Now I can cancel this a square and minus a square, and can I take, what can I do now? Minus b square minus ab. So can I take minus b common? If I take minus b common, that will be b plus a, and here I can take minus y common, that will be a plus b. Now can I cancel out entire a plus b and a plus b? Yes, I can cancel out entire a plus b and entire a plus b. Can I do any furthermore cancellation? Minus minus. So finally, what is the value of y I got? The value of y is b. Once I got the value of y, substitute in any one of the equation and again pull out the answer of x. So we know that x plus y is equals to a plus b. We already know the value of y is b. So can I cancel b? So the answer of x is a. Yes, isn't it very simple, right? I got the value of x to be a, the value of y to be b. Yes, yes. Now let's see furthermore few more questions, right? Now let's see few word problems. If you see here, the sum of numerator and denominator of a fraction is 18. If the denominator is increased by 2 and the fraction is reduced to 1 by 3, find the fraction. Be very careful, there are so many ages problems, fraction problems we need to solve. We can solve actually by linear equation in two variable. Now let's try to understand. He is saying the sum of numerator and denominator of fraction is 18. Now when can so there are two quantities involved, that is numerator and denominator. So we need to assume some of the variables, right? So let the numerator is equals to x, the denominator is equals to y. So generally the fraction is in the form of x by y. This is what I'm saying, right? Now he is saying the sum of numerator and denominator is equals to how much? 18. Now if the denominator is increased by 2, so here there is no change in the numerator. He is saying if the denominator is increased by 2, so what is happening? X by y plus 2, the fraction reduces to 3. Okay, here understand this, the fraction is reduced to 1 by 3, not, there is a difference between reduced by 1 by 3 and reduced to 1 by 3, right? It is reduced to 1 by 3, 2 means you can just directly write 1 by 3. Now you can crisscross the equations, right? Now what will this equation be? 3x is equals to y plus 2, right? Or you can write here only y is equals to 3x minus 2. So we have two equations, this is equation 1 and this is equation 2. Can we solve these two equations? Just substitute in place of y 3x minus 2, x plus 3x minus 2 is equals to 18. So just send the 2 on that side. What is x plus 3x? That is 4x. 18 plus 2 is 20. X is equals to 20 by 4, which is 5. So you got the numerator value to be how much? 5. Once you got the numerator value, substitute in any one of the equation, in place of x substitute here. So if you try to substitute here, 5 plus y equals to 18, y is equals to 18 minus 5, that is 13. So you got the final fraction to be what? X is how much? 5 and y value is how much? 13. Now you can re-verify this answer once again. If you add numerator and denominator, what is 5 plus 13? 18. Did you get the answer? Hence, you can again validate your answer from the question itself, right? Right. Okay. Now, so these are some of the ways in which we can actually, these are the concepts that we have covered till now is based on linear equation in two variable, right? It's a brief runaway with the concept, like we have completely seen the synopsis part, we have solved few problems based on linear equation in two variable, we have entirely covered what is a graphical method, what is the algebraic method, in algebraic method what is a substitution method, what is an elimination method. We have seen several problems in order to understand briefly how does a linear equation in two variable works, right? Right now we would further dive into the concept and with a new chapter, that is quadratic equations. Now what is this quadratic equation? Is it new to us or did we study somewhere before? And we are going to see mainly in this the roots of a quadratic equation, and further we would like to find how do we find the roots of this equation and what are the nature of roots, right? What is this root? And we are going to understand these terminologies and keywords in this quadratic equation, right? Yes. So you might have already seen, we have studied in the morning a linear equation in two variable. What is a linear? The highest power or the degree is 1, right? But when I say a quadratic equation, what is the highest power? The highest power is 2, right? We have already confronted this sort of a topic in the polynomials also, right? We have seen something called as second degree polynomial, right? The second degree polynomial and quadratic equations analogously they go in a similar way, right? The meaning and the understanding is almost simple, right? If you have done some simple concepts in polynomials, this becomes much more easier. Further do, it is not necessary, even without that we can understand this in a better way, right? Right. Let's understand what is meant by quadratic equation, right? An equation is something which has equal to sign. Yes, we have studied, but in the morning we have studied linear equation in two variable. Today we are going to see the quadratic equation. In quadratic equation, what is the highest degree we have? The highest degree is 2, right? So in quadratic equation in a variable x is in the form of ax square plus bx plus c, where a, b, c are real numbers. Understand this, a is never equal to 0, right? Then only if a is tend to be 0, it becomes a linear equation. Can you see here, right? It becomes a linear equation, right? So that's one of the main concept, right? Now let's understand this. So what is meant by roots of quadratic equation? Okay, so we have already seen, right, in the polynomials what is meant by zeros of a polynomial, right? A zeros of a polynomial is, suppose if there is a linear polynomial, or if it is a quadratic polynomial, right, or if it is a cubic polynomial, the point at which it is exactly meeting the x-axis is called the roots of a quadratic equation or the zeros of a polynomial, right? If you see here, generally a quadratic equation is always in the form of a parabola. Okay, it is in the form of a parabola, right? Now this parabola intersects the x-axis in how many, like how many times it could be intersected? Only 2 times, or we can take some different possibilities also. How many times is it intersecting here? It is intersecting at only 1 time. And how many times it is intersecting over here? It is intersecting 0 times. There is not even 1 time that these two parabolas are intersecting, right? So let's understand the roots. The roots means it is almost equal to the, it is exactly equal to the 0 of a polynomial, right? Now let's understand this. Okay, so for a polynomial 2x square minus 5x plus 3 equals 0, verify whether it is a 0 of a polynomial or is it called the root of a polynomial or not. Simply you need to do only one thing. You need to just substitute in the equation. If it is getting agreed or if it is getting equated to 0, you can call it as a 0 of a polynomial, or you can call it as a root of an equation. We'll quickly wind this up. 2x square minus 5x plus 3, substitute 2. So what is happening? 2 square, 4 2s are 8, minus 10 plus 3. What is 8 plus 3? 11. 11 minus 10 is 1. Now is it equal to 0? Can you say that 1 equal to 0? No. So can I say that 2 is the root of this quadratic equation? The answer is no. The answer is no. We cannot say that 2 is the root of equation, right? But if we try to substitute the value of x again, so what is happening? 2 into, in place of x, just substitute 1 minus 5 into 1 plus 3. So 2 minus 5 plus 3, 3 plus 2, 5, 5 minus 5 is 0. Yes. So if you see here, the LHS and RHS both are equal to 0, hence they both are agreeing, hence I can say that 1 is called as root and but 2 is not called the root, right? That means pictorially, if you try to see, this parabola is intersecting at x equals to 1, right? Right. Okay. Let's try to see one 2-mark problem based on one previous year question. So if 1 by 2 is the root of a quadratic equation, find the value of k. Simple. Just now we have seen, he has already said that 1 by 2 is the root of the quadratic equation, right? Now what is happening if I just try to substitute in place of x 1 by 2? So that will be 1 by 2 square plus k into 1 by 2 minus 5 by 4 equals to 0. So that will be 1 by 4 plus k by 2 minus 5 by 4 is equals to 0. So if you try to see, 1 by 4 minus 5 by 4 plus k by 2 equals to 0. What is 1 minus 5? Minus 4 by 4 plus k by 2 equals to 0. So 4 gets cancelled. So this will be minus 1 plus k by 2 equals to 0. If I try to send minus 1 to the right hand side, what it becomes? K by 2 is equals to 1 and k value is equals to. So simple, right? It is just a 2-mark problem. We have just solved it within a fraction of 2 minutes, right? So this is how, whenever I say that any number is the root of a quadratic equation, you don't have to do anything. Just directly substitute the value in that particular equation in place of x and generally find out the answer, right? It is as simple as that, right? Right. Now, is it possible to find the root of a quadratic equation? Is it possible to find the root of a quadratic equation? Yes, we can always find the root of a quadratic equation, right? There are 2 ways in which we can find the roots of a quadratic equation. One is through factorization and one is the quadratic formula. Now, this quadratic formula is a very strong and a very important formula. This factorization technique we have been learning right from our smaller grades, but right now I would like to make you understand this factorization is also called splitting the middle term. It is also called splitting the middle term, right? Right. We will understand this, what is splitting the middle term, right? Now, find the solution of a quadratic equation x square minus 5x plus 6. Okay. Now, let us take this quickly. We will take this x square. We will try to understand this in a very quicker way. Now, how do we do this splitting the middle term? Understand this step by step. First of all, there is the coefficient of x square, which is 1, right? You need to multiply the coefficient of x square and the constant. First, you need to multiply the coefficient of x square and the constant. So that is the first step. What is step 1? Step 1 is multiplying the coefficient of x square and the constant. So what is 1 into 6? The answer is 6. Now we need to further find the factors of 6. What are the factors of 6 we have? 1, 6, 2, 3. Yes or no? Now, splitting the middle term, we need to split the middle term with some numbers, right? How many combinations we can split this minus 5? We can do it in infinite possibilities. But out of those infinite possibilities, we are trying to find some numbers in such a way that if we add the 2 numbers, we need to get minus 5, and if we multiply, we need to get this 6, right? But if you see here, what is 1 plus 6? 7. 2 plus 3? 5. Is there any way that we can get minus 5? According to these numbers, no. But there is another way that we can get minus 5. What is minus 2 minus 3? What is minus 2 into minus 3? It is 6. But what is minus 2 plus minus 3? It is minus 5. Don't you think so? Can I write minus 5 as minus 2 plus minus 3? But what is minus 2 into minus 3? It is again 6. So here I have chosen my factors in such an intelligent way, right? If you see here, minus 2 into minus 3, I got 6. But if I add minus 2 and minus 3, I am getting minus 5. So you need to be wise enough to choose these factors and then split the middle term. Now the concept is very simple. Now x square minus 5x, I can split it as minus 2x minus 3x. plus 6 equals to 0. Now what can I take common? You can take x common. If you take x common, and what can you take common in these two? You can take minus 3 common. So this is x minus 2. So what can you take common in the whole thing? You can take x minus 2 common, and you can take x minus 3 common. Now you can individually equate it to the right hand side. So this will become x equals to 2, x equals to 3. So this x equals to 2, x equals to 3 are called the roots of the quadratic equation. Again, I would like to quickly once more wrap it up this concept. See, first you need to choose the coefficient of x square 1 and the constant 6. You need to multiply this 1 into 6 and then again split this, and we need to find the factors of 6. We need to choose the factors in such a way that if we add the factors, we need to get the middle term. So I have chosen in that way minus 2 and minus 3, and then I have split, then I have taken the common, and this is how I get the final answer. Now this is how you do the procedure of factorization or the splitting the middle term, right? Okay, right. Now we would like to solve one problem using the splitting the middle term, right? The difference of two numbers is 5 and the difference of their reciprocal is 1 by 10. Find the number. Okay. So if I have to choose two numbers. Do I know the two numbers? So let's take one of the number to be, let the number be x. Can I find out one more value? That is, let the another number be x plus 5. Now if I try to take the difference between these two numbers, x and x plus 5, x plus 5, like x plus 5 minus x, again I will be getting 5, right? Now the difference of the reciprocals, okay, now the difference of the reciprocals, what is the reciprocal of x? It is 1 by x. What is reciprocal of x plus 5? It is 1 by x plus 5. Now that is equals to 1 by 10. Now can I do the LCM? X plus 5 minus x by x times x plus 5 is equals to 1 by 10. So can I cancel x? So from this I get 5 into 10, I am trying to crisscross, is equals to, what is x into x? X square plus 5x. So the answer is 50 is equals to x square plus 5x. Now if you try to observe this quadratic equation, right, x square plus 5x is equals to 50, x square plus 5x minus 50 equals to 0. Now how did we do just now? We have seen splitting the middle term. You need to take the coefficient of x square into the constant. 1 into minus 50 is minus 50. What are the factors of 50? Can I say 10 5 is 50, right? Now so x square plus 10x minus 5x minus 50. Just see, did I choose my factors in that way? What is 10 into minus 5? Minus 50. What is 10 minus 5? 5. Did I choose my factors in that way? Yes. Now can I take the x common? So that will be x into x plus 10, x plus 10, you can take minus 5 common. So now what can I take common in the entire thing? This x plus 10 and x plus 10. So x plus 10 times x minus 5. So we have x equals to minus 10 and x equals to 5. So we got the two numbers whose difference is 5 and whose reciprocal is 1 by 10. So these are the two answers we got, x equals to minus 10, x equals to 5, right? So this is how we can solve even the word problems using quadratic equation. Remember, we can solve daily life problems using the quadratic equations. Okay, right. I said there is one last formula in the entire section. Now this is the culmination. This is one of the climax of the entire chapter. We are trying to use, this is one of the most strongest formula. The factorization technique cannot be applied for every problem, right? It cannot be applied to every problem in the quadratic equation. It can be applied to a decimal of percentage of problems that you can solve using factorization technique, right? But whereas this formula, it gives us a very clear picture of, we can use this formula to any quadratic equation and we can find the solution or the roots of a quadratic equation, right, using this formula. Understand this, if the quadratic equation is ax square plus bx plus c, we can find the roots by using this formula. X is equals to minus b plus or minus under root of b square minus 4ac by 2a. Understand this, b square minus 4ac is called discriminant. What it is called? Discriminant. Based on this discriminant, we will try to further classify the problems. Okay. Now, please see here. Right, just now I said what is this discriminant? D is nothing but b square minus 4ac. If this d is greater than 0, we can say the roots are real and distinct. That means the parabola looks like this, right? If the d is equals to 0, that means if you try to exactly see, it is just touching at only one point. Here you can see the root is only 1. Here you can see there are 2 roots, right? This is how graphically it looks like, right? And if d is less than 0, like, is there a possibility that we can draw a parabola that it never intersects the x-axis? Yes. So if you see here, I can always draw a parabola like this. So if you see here, is it intersecting anywhere x-axis? No. So here, are there any roots? There are no roots, right? Here, are there roots? Yes, there are 2 different roots, right? There are 2 different roots, and there is only one root where it is intersecting the x-axis. So when d is greater than 0, we have 2 distinct roots. When d is equals to 0, it is having a unique root, right? That is a real root, one real root. And then d is less than 0, then there is a no real root. That means there is an imaginary root, right? So that is what you would like to see. Understand this: d greater than 0, 2 distinct, d greater 2, d equal to 1, d less than 0, right? This is how we can further classify. Okay, see, if the roots of a quadratic equation are 4x square, okay, 4x square minus 5x plus k equals to 0 are real and equal. Understand, when can we have real and equal? Whenever the roots are d is equals to 0. Now what is this d? Discriminant is nothing but b square minus 4ac, b square minus 4ac. Now we have the equation in the form of ax square plus bx plus c equals to 0. Now what is the value of a? A value is 4. What is the value of b? B value is minus 5. What is the value of c? The c value is k. Now simply we need to use this formula and equate it to 0, because he is saying it is real and equal, right? Now what is b square minus 4ac? Simple, b square minus 5 square 25 minus 4, a is 4 into k, right, is equals to 0. So 25 minus 16k is equals to 0. So can I say that 25 is equals to 16k? So the value of k is 25 by 16. Simple. So if you just understand the concept, that is, if it is real and equal, so that means discriminant equal to 0. Suppose he said that real and distinct, then d is greater than 0. If he is saying there is no real root, then d is less than 0. So just by using this subtler concept, we can find out what is the value of k using this small key points, right? Right. Now he is saying if the discriminant of the quadratic equation is of the equation 3x square minus 2x plus c equals to 0 is 16. He has already given the discriminant. What he has given? The discriminant d is equals to b square minus 4ac. He has already given the value is 16. So when he set 16, now you know how to squeeze out the points of a, b, c. What is the value of a? 3. What is the value of b? Minus 2. What is the value of c? The c value is c itself. Now can you just substitute in this formula? Just small substitution. B square minus 4ac minus 2 square minus 4, 3 into c is equals to 16. So 4 minus 4 into 3, 12, c is equals to 16. So 4 minus 16 is minus 12 is equals to 12c. So c value is equals to minus 1, right? The c value equals to minus 1. Just reading the problem, understanding, just memorizing this b square minus 4ac, we are done with the problem, right? Right. So this is what the formula we have discussed, right? The roots of the quadratic equation is given by minus b plus or minus under root of b square minus 4ac by 2a. You can also rewrite this formula as minus b plus or minus under root d by 2a. What is this d called? It is nothing but b square minus 4ac. You can rewrite this formula, right? Now, yeah. So let's see. Find the discriminant of the quadratic equation and hence find the nature of root. So you don't have to do anything. Blindly first find out the b square minus 4ac. Whenever he is saying discriminant, what is the discriminant? B square minus 4ac. So what is a, b, c value? Just list out. A value is 3, b value is minus 2, c value is 13, right? So b square, it is minus 2 square minus 4, a value is 3 and c value is 13, right. So now what is minus 2 square? 4 minus 4 into 13 3s are 39. So you can take 4 common. So if you take 4 common, 1 minus 39, which will be 4 times of minus 38. So you will be getting some answer in terms of negative. It doesn't matter whatever the discriminant value is, but this value is less than 0. Hence, if the discriminant value is less than 0, then the nature of roots are there are no real roots. Always remember, d greater than 0, then it is having two distinct real roots. If d is equals to 0, there is only one real root, okay, and real and equal in fact, okay, and d is less than 0, no real root, okay. It goes in this fashion and this pattern, right. Okay, so here comes the end of the lecture. We have somewhat covered the concept totally of linear equation in two variable as well as the quadratic equation. I hope you thoroughly enjoyed the concept and the PYQ questions. And here comes the conclusion. I would like to say that this is the QR code scanner of sisyaclass. You can join our classes using this scanner, right, and you can subscribe to our YouTube channel as well. And I hope you thoroughly enjoyed our lecture, and thank you so much. Please like, share and subscribe the Sisya classes. Thank you and have a great day.